Welcome to the November Research Pays Off. My name is Lauren Dow. I'm the Communications Coordinator for the National Road Research Alliance and the MnDOT Office of Materials and Road Research. We are delighted today to have Tom Burnham, who is going to speak about some of MnRoad's contributions towards improvements in concrete pavement technology. Tom works here at the MnDOT Office of Materials and Road Research, and he is a senior road research engineer, and he has spent much of his time, from what I have gathered, in the field of concrete. So I'm sure he will have lots to share with us today, and a reminder that you are welcome to ask any questions in the chat box, and we can go through any questions or comments at the end. And I think that's all I have to share. It looks like everybody's muted. I think we're all pretty well versed in maintaining that these days. So yeah, enjoy what Tom has to share.
All right, thank you, Lauren, for the introduction, and good morning, everyone. Thank you for this opportunity to give you a summary of at least what a couple of our staff members, longer-term staff members at MnDOT that have been involved in MnRoad, feel that we feel that what has really come out of this and how has it affected the concrete pavement technology industry. Before I begin, I'd like to acknowledge my co-authors. Much of this presentation stems from work that we put together, a TRB paper last year. It was published, very similar title. I had altered it a little bit because I have some updates. But again, I want to thank Bernard Izowekai and Ben Worrell for helping complete this paper that really looked at, really what's been accomplished related to concrete pavement technology over the past 25 years. Just an outline of today's presentation. I'll give a brief history of MnRoad for those that aren't really familiar with the project and how it evolved. And then I'm going to spend most of my time, again, outlining the significant contributions to concrete pavement technology that we feel have come out of this facility, related to design, materials, construction, rehabilitation, pavement monitoring, evaluation, and full-scale testing. And then I'll wrap up the presentation talking a little bit about the future. So the MnRoad facility, for those who are kind of new to it, it's a full-scale test track in kind of mid-section of Minnesota. Has a couple components, 3.5 mile mainline section here that receives interstate traffic that's diverted off of a parallel section of I-94. And then there's a 2.5 mile low volume closed loop test loop, which receives trafficking from one legally loaded semi-truck tractor trailer. MnRoad is kind of unique in the nation, the fact that it has all the different materials. There are other test tracks in the US and around the world that are focused on one specific material. This particular facility covers all the material types, predominantly asphalt and concrete. And then if you want to talk about composite pavements or overlays, that has also been incorporated into the facility over the years. Operations began in 1994, and one of the unique things, of course, it's run by a public agency, so the data is freely available. And really, what it provides is opportunities for bold ideas. This is a place where you can afford to fail because we have the opportunity to switch traffic off, back to the old main line of I-94, or if something happens on the low volume route, we can shut down operations of the truck. So again, we're celebrating over 25 years of operation. It's been a fun ride. Talking a little bit about the operational history, the facility itself, planning started in the late 80s, and it took, again, up until 1994 to get it constructed. It was constructed for about $25 million, and that was back those 1994 dollars. If you were to construct this facility today, it'd probably be 3 or 4 times that amount. So it really was an incredible investment by MnDOT to build this facility. Phase 1 was again funded by MnDOT and the Local Road Research Board, which receives a fixed amount of state tax to look at local road research issues. Again, that kind of predominantly focuses on that low volume road loop. And we also received FHWA funding. And when it started, you know, all the experiments were determined by MnDOT and the Minnesota Local Road Research Board because all the funding was coming from that. Then in phase 2, about 2007, we started adding some pooled fund partners in addition to the MnDOT and the Local Road Research Board and FHWA funding. So we started becoming a little bit more of a national facility. And some of the experiments, again, were not totally determined by MnDOT anymore. There was starting to get some interest by national partners, and something maybe another state wanted to study, and we would put it on here and study it for them. And now we're in phase 3, which began in 2015 with the institution of the National Road Research Alliance. And as of recently, or for the early years, we had 8 states join, along with the Illinois Tollway, and again, the Minnesota Local Road Research Board maintained their presence. Construction remained with MnDOT, but then again, we started receiving some construction money and help from partnerships. And the big shift now is that all experiments are determined by NRRA members. Again, this includes not only state agencies, but other industry and academia members. And I'll talk about more of that near the end of the presentation. So looking specifically at the concrete pavement related history, you know, the sections that were concrete pavement test sections on MnRoad, you can see we've had quite a number of sections. Phase 1 really kind of focused on validation of what we were using back then in the early 90s, the AASHTO 1993 design, and specifically there was test sections on the mainline section that were designed to last 5 years and 10 years according to those design procedures. And then there's also some other related studies, materials, low volume road designs. And then kind of near the end of phase 1, we started looking more and more at white toppings and bonded concrete overlays of asphalt because those were starting to become popular and they wanted to learn more. So we started constructing those. Phase 2 opened up again. We started getting pooled funds, so we get a little more breadth of the type of topics we're looking at. Again, more white topping sections. Some of the things we were starting to see from the first phase was that the AASHTO designs were very conservative, so the question was, well, how thin can we go? So we constructed some very thin sections, and that's really one of the things about this facility is you can take those chances that if it fails, you still have the opportunity to switch traffic off and kind of address the issue. Some of the other things, national studies, composite from the SHARP 2 program. Pervious concrete became kind of a popular thing. Started studying that. And as well as, again, revisiting the use of recycled concrete aggregate in the concrete pavement itself. Now, phase 3 is kind of addressing today's issues. So again, looking at early loading. You know, there's a lot of interest in being able to load the pavement sooner than we can. Driving down the cementitious content for sustainability purposes. And of course, and also this interest in fiber reinforcement, especially in the overlay arena. So I'm going to give you a little bit of summary of what we feel is some of the significant contributions, related to improving the knowledge, implementation of findings. I'm talking about some of the test equipment that's been either evaluated or developed at MnRoad. Talk a little bit about what did not work, which actually in the realm of pavement research is a benefit to the people because you can avoid, rather than doing miles and miles of something that's going to fail, you can do a short section and we can tell ahead of time that it's something you probably want to avoid. Also touch on some of the contributions to some of the national studies that Minroad has been an instrumental part of. So the first thing that I was involved with as a young engineer was kind of using the as-built features of the test cells and kind of predicting, now that we built the cells, how long do we predict they're going to last? Because we know what you design and what you build is different. There's different properties that come out. There's variations in thickness. But in any sense, those 5-year design test sections, which were ML5 to ML9, you can see here's how long they actually stayed in service, anywhere from 14 to some are still going after 25 years. So it's very interesting. And you could also see that some of, you know, the very conservative nature of those older design procedures that we're using at the time. Even the 10-year design sections. And some of these, it's not that they wore out, but we just felt that the experiment, you know, there was better things to study. So we knew that it could go longer, but we decided to replace them with different studies. So again, we still have a number of sections that are out there after 25 years that were, you know, it gives us the opportunity to really develop long-term performance curves for these sections. So I would say the design efficiency award goes to the test sections 7 to 9 on the interstate. These were 7.5 inches of jointed plain concrete pavement, over 4 inches of permeable asphalt stabilized base, over 3 inches of granular base. Nothing to do with what people are talking about. You need 3 feet of frost-free design and everything. These things have performed stellar. The only thing they had was that they were constructed with 1990 mixes that tended to deteriorate on the surface. But as far as within the joints, we had very, very little deterioration of the joints, predominantly because, again, the drainage, that permeable asphalt stabilized base was consistent and it provided very good drainage. So it really, again, points to some of the thoughts of back in AASHTO where you need 12 inches of design in an interstate. This kind of demonstrates that that was a very, very conservative designs, and we could probably go thinner. So speaking of thinness, that's kind of where this headed. And, you know, in some respects, it's kind of interesting that you're trying to do concrete pavement research when you know concrete pavements are supposed to last a long time. How do you learn anything? Well, one thing you do is you start thinning out, and that's really where a lot of the experiments headed. Some of that thinness just dealt with the fact that we were studying white toppings, you know, something put on asphalt where you have a good support already. You can see all the various thicknesses that we were testing. You know, these are crazy thin sections for most interstates. Yeah, so you can see that's why, again, we're out to accelerate really the mechanisms and understanding what the failures might be. Again, you might not ever put a 5-inch on an interstate, but it's certainly going to tell you sooner what's going to happen if it were to put on a lower volume road. And really the ultimate one was the concrete thickness optimization experiment, where we just incrementally increased it by 1/2-inch increments, and we're able to understand that in the end, really 6 inches is about as thin as you can go and still have a factor of safety in your design. Anything thinner, it lasts for quite a long time. I mean, several million easels, but any little bit of ununiform support in the base, it really popped through right away. So it really told us that our good rule of thumb that 6 inches is about as thin as you can reliably go. You can see here at the end also, we're starting to learn things fairly quick on these really thin, ultra thin fiber reinforced concrete. We have one section that's already gone after 2 years. So again, just really pushing the limit. We learned the age-old lesson that drainage is key. Your design has to have drainage. Otherwise, this happened to be a panel removed for a forensic activity, and you can see just the water from a rainstorm. It sat in there for 3 days before it was gone. So that kind of tells you our older designs with the dense graded aggregate base, no edge drains, this is what you get, and this is why the joint deterioration accelerates, at least in our climate. So we all know that drainage is key, and this really is a very graphic example of really what happens underneath your pavement. So one of the technologies that we tried at Minroad involved, not a new idea, because I think this is pretty prevalent in Europe, but the understanding of putting some kind of a geocomposite joint drain underneath just the joints. For the most part, we don't get a lot of joint deterioration between the panel, between the joints. The slabs are okay, but if you were to pull out the panels after several years of our climate and those older mixes, you find a lot of joint deterioration. So this is one easy way we felt to do it. And the ironic thing is, it's one of those cases where we had just installed this, and within a year, this was already being implemented on network projects. We kind of said, well, we're not even done the research, but it just makes sense, and we know that it's kind of a proven technology in other countries. It also allows you, again, to use those more dense graded bases, because really you're just draining where it has to be drained, and that's in the joint location. The long-term seal to not seal, there's questions answered and raised by, work at Minroad. We got, in this left-handed case, it's a white topping. So when the water gets past your asphalt seal, it has to be kind of partially sealed. It seems to trap water. We got tremendous, deterioration within a short amount of time. We had other cases where there was no seal, and you can see pulled out, there was no deterioration. So I don't know, that it's really specific to your situation, but really the ultimate answer again is drainage, drainage, drainage. And I think we've also learned that some of the materials that we're using are not long-term solutions to providing something that seals out water. Again, sometimes it's better not to have a seal than something like a partially sealed joint. As a result, you can see that our current MnDOT specs really, except on low volume road situations, we really got out of the business of using joint seals, at least until better materials can be come up with. Minroad has been a very big contributor to understanding surface characteristics for concrete pavement. We've had every single kind of texture you can imagine, addressing noise, safety, the durability of texture, as well as being able to construct it. So we've had all these different things, and tremendous knowledge has come out of just examining all these various textures. Minroad data has also been very instrumental in helping the improvements of design procedures. It kind of coincided with the development of the pavement ME. So over this whole period from the early 2000s till now, a lot of model calibration and understanding has come out of Minroad data. It's also helped develop a new mechanistic empirical procedure for bonded concrete overlays and asphalt, or white toppings, as well as a recently completed unbonded concrete overlay design study. It's also been used to calibrate the current design procedure that MnDOT uses, as well as some of the national lower volume road design procedures. And we've given out numerous data, we get numerous data requests internationally, so while we can't account for it all, we do understand that there's other people around the world using Minroad data that is influencing their design procedures. As far as materials, we've studied a lot of different materials, anywhere from high performance mixes that are designed to last 60 years to recycled materials. Again, not only just using concrete aggregate underneath as a base, but also within the concrete. More recently, there's been a lot of focus on determining whether we can figure out the benefits of structural fibers, at least the synthetic structural fibers. We've looked at pervious matrices, whether it's an overlay or on grade. We've learned a lot there. We also have a section where we put corrosion-resistant dowel bars. Still working on summarizing the results from that, but again, I think I've not seen any detrimental impact of using that in that particular test section. We've also studied a number of alternative joint load transfer devices, anywhere from joint stabilizers to plate dowels. So again, looking at the effective drainage on the materials, we can see again the difference that we saw with a slow draining base, like a dense graded class 5 base versus something that's permeable, just night and day performance. And again, this is somewhat a factor again of the type of mixes. You can see the type of mixes that we used back in the early 90s. I think we've made substantial improvements to the mix designs we use today. And we would hope that even if you had not ideal drainage, you would never get something that looked like that with the particular mixes that we're using today. Min-Roads hosted a number of concrete repair material evaluations. This one here beginning in 2011, run for about 3 or 4 years, and you can see, time-lapsed study of how these things, the various materials perform over time. It's been very instrumental in understanding that. Again, now a lot of work with reinforced concrete. Fiber reinforced concrete actually began back in 1997. However, I would say back then we had only one section that had what we would consider now as a structural synthetic fiber. And in fact, we were a little bit naive at the time, and they said, well, you need 25 pounds per cubic yard. So we put that in, and it actually became detrimental to the pavement. And, that particular section is actually still out there performing, but all the joints are just deteriorating, and it's likely due to the overdosage of the fibers. But the other particular sections had what we would consider today microfibers, which had little impact on any kind of performance. Min-Road has always used real construction, so we've had to push the contractors into very uncomfortable situations, whether it's trying to work around sensors or paving something extremely thin, which you wouldn't think would be an issue, but again, they're used to designing 8-12 inch, paving 8-12 inches, and when you tell them to pave 3, it gets very scary, especially when you're trying to pave over very delicate sensors. But we've learned a lot from that. We've also did 2-lift construction sections with the Sharp 2 program that turned out pretty successful. The contractors have had to deal with uniform distribution and mixing of the fibers, which is always a challenge. Lately, we've pushed them. It's not so much them, but just the construction aspect of whether we can open things much earlier than we think. So the experiments have taken place related to that. We've dealt with pervious concrete construction using roller screed and understanding some of the issues with that. Some improvements in the use of geotextile interlayer and how that's secured to the pavement, as well as, again, monitoring and testing devices that are related to construction of concrete pavements. So here you can see a picture of cell 139, which was a 3-inch fiber reinforced concrete. And if you start thinking about 3 inches, that's actually thinner than a sidewalk. But the contractor did a very good job in pulling that off, and it was a very consistent section. It's unfortunately the section, as we might expect, failed very quickly. But again, we learned, and we learned something about whether the fibers contributed to the strength of that particular section. Talked about, again, this may not have been the first application, but it's probably one of the first times where there was a contractor interested in learning, you know, can we secure this fabric differently than trying to nail it down? Because using nails into concrete, you had maybe a 50% success rate. So we got involved with, I think it was 3M came up with something that, you know, you just spray in the pavement and you stick it down, and it actually worked very well. And I think this is kind of the adopted standard now. So again, I'm not sure if this was the first application, but certainly was a high profile instance of, you know, trying this procedure. Again, this shows pervious concrete, you know, kind of learning about whether it's better to form or saw the joints. I don't recall. I think the form joints did not perform as well as something using the saw joints, but I think a lot was learned at Minrode about pervious concrete, and again, there's several reports available for looking into how that worked. And it was tried both on grade as well as a thin bonded concrete overlay on another section. There's been a tremendous amount of work done in the development of diamond grinding, and a lot of the things that are excuse me, used worldwide now stem from the initial work that started in the Purdue laboratory, and then it came out here. You can see on the low volume road with 1-foot strips of the various textures that were tried. And from here, then it went out to the main line, and shortly thereafter was a full scale on projects. So again, Minrode was heavily involved in the development of the next generation concrete surfacing that's very popular now. Early loading, again, this is something that happened only 3 years ago, where again, people say, well, one of the problems with constructing concrete pavements, they take too long before you can put traffic. So we wanted to kind of answer, well, how soon can you put traffic without causing some kind of immediate or long-term damage? And you can see here, even before the joints were sawed, we were out on there 3 years old, 3 hours old, you know, running this happened to be an empty plow truck. But nevertheless, we did not see, and we still today do not see any of that loading. So I think we're still learning. I think last week I was out and I did notice that some of the transverse joints seem to be opened wide, but again, a lot of this loading occurred before those joints were even sawed. So it's kind of an interesting. But as a result, there are people who have gained a much higher comfort level of putting specifications out there that pavements can be opened, especially to lighter traffic, much earlier than they used to be. Minrode has always prided itself on using the latest and greatest testing devices. So we always try to acquire the latest and greatest and use it for as many as we can. In the lower right corner, this is even equipment that was developed specifically at Minrode. It's a sweeping lasing profiler used for warp and curl measurements. Again, we're probably not the first, but again, we made pretty specific equipment that would accommodate the longer panels. Again, this is over like a 15-foot beam to accommodate the widened sections and doing some of the longitudinal and diagonal measurements. Up here is the automation of the Georgia fault meter. So we took a simple device, made it complicated by throwing a laser on there, but again, for convenience, for the amount of data that we have to collect, we really needed something where you weren't just writing each measurement on a piece of notepad and then having to transfer it. In fact, we're in the process of actually upgrading that again. So again, it's a very useful tool we use not only on Minrode, but on other outstate studies. Very recently, we got this device called the MIRA, which is an ultrasonic tomography device, and it's very interesting tool that gives you almost kind of an X-ray vision into the concrete. It really bounces, the technology bounces sound signals off of interfaces, and as you can see here, it does a fairly well representation of detecting even this ramped void underneath this joint that was intentionally constructed for this testing purpose. But this tool is actually being used quite a bit now for detecting deployment of joints, whether after the saw cut is formed, whether it actually cracks all the way through, and which is an important feature, especially for concrete overlays. Min-Road has been, again, instrumental in using and also improving the technology related to surface characteristics. Again, there's a lot of development work, improvements made on the OBSI tire pavement interaction, the noise related to that. A lot of that work, again, was done at the Min-Road facility. Some of the other devices, again, maybe not so much improved, but again, just utilizing the latest and greatest instrumentation or testing equipment that we could find. This impedance too was developed in-house, again, looking at noise absorption. And also, again, we use both the typical pavement management vans for doing our profiling, as well as a much more research level by mounting lasers on a small lightweight vehicle. And over the years, again, these lasers have changed anywhere from a point laser now to a line laser, area laser. There's all kinds of developments. Again, it's a perfect facility with all these various textures, to really evaluate what you can do with these particular lasers and how it affects the outcome. As Min-Road aged, of course, in the real world, everything now is more rehabilitating the pavements rather than laying new concrete down. So the experiments also kind of mirrored that. And so a lot of work has been done on concrete overlays, whether it's white topping or unbonded concrete overlays, even, again, pervious concrete on concrete. Repairs, as we keep some of those original sections around and the joints got deteriorated, we experimented a lot with both full depth and partial depth repairs. So looking at retrofit dowels, various materials for repair. Again, looking at what kind of repairs can we do on very thin slabs? So we had the opportunity there to really examine even the difference between a small diameter steel dowel and a plate dowel. This shows you some full depth repairs that were done on the low volume road, kind of an empirical study. Again, these particular dowels were called Kovex dowels that came out of the industrial flooring industry, and there was interest by them to understand whether they could be used for pavement rehabilitation. So the experiment was, let's try 5, 6, and 7 of them across, and eventually we discovered that once you get up to about 6 or 7 of these, they actually perform very well on a low volume road. However, that was a 6-inch pavement. They were utilized here in repairs done to a 5-inch concrete pavement, which again was in fairly poor condition when we did this, so there was a lot of voids underneath. It was probably a lot to ask, but again, you can see almost the pattern from the surface that these particular dowels had high enough stresses that they really kind of blew through the old concrete pavement, not so much the new concrete patch. This particular section also had that situation where we tried retrofitting dowel bars, both the round and the plate dowel bars. Not so much the round ones, but also just long plate dowels, looks like maybe a xylophone key. Some of those worked pretty well, others did not. Again, the pavement monitoring and evaluation, Min-Road has been instrumental in the fact that we've done seasonal FWD testing. So we have this 25-year history of seasonal FWD testing. That's, I think, been invaluable to a lot of studies and development of design procedures. The FHWA has taken advantage of all those various surface types that we have. You know, they're able to conduct rodeos and do a lot of calibrations. And in fact, MnDOT MnROAD is used every spring for certification of our contractors' profilers every year. So it's been a very useful facility for that. Although I have to say that in the beginning, they used both asphalt and concrete cells. They discovered that concrete panels move around a lot, so they've kind of taken some of that certification strictly to the asphalt pavements. So again, lessons were learned, you know, over the time that it became difficult to do certification when the panel's warping and curling all over the place throughout the day. MnROAD has hosted a number of demonstrations and calibrations of rolling weight deflectometers, which I think we all hope are the future of evaluating pavement. You know, you can cover a lot more area than just a static FWD. Rolling resistance, we actually had someone ship over a specific device from Poland to actually measure rolling resistance. We also instrumented the MnROAD truck and took it around. So there's been a number of studies relating to rolling resistance, and we know that that has been kind of an interest of the concrete center at MIT, you know, looking into the effect of rolling resistance on fuel economy. MnROAD's also been a huge partner and contributed to the long-term pavement program, and in fact, we are utilizing, you know, part of their database so you can get MnROAD data off the InfoPave website. So, being one of the few full-scale pavement testing facilities in the U.S., you know, we've been able to learn a lot of things over the years that are now being shared with others that are either running or are starting to build their own. Anywhere from looking at how to best install instrumentation. I think we've gotten fairly good at it. We have a pretty high success rate. We've also had some lessons learned where we tried some things that didn't work so well. You know, if you put wires underneath directly on the grade, we find that they get kind of scrubbed off with the movement of panels, and the wires get severed pretty quickly. So there's been a lot of things tried, and I think it's been a very interesting process. One of the things also we're learning is that, you know, these instruments don't give you exact measurements. They're relative, because it's very difficult to understand their particular orientation with the slab, even sometimes where they're located. You know, there's variability in the depth of pavement. You know, as controlled as we are, it's still difficult to again, the bottom line is you can't use them as absolute values. These are relative measurements that come out of these particular sensors. We did learn that it's okay to have shorter test sections. You know, some people say, well, you need 1,000 feet. No, I mean, we've had sections that are only 18 feet that have had 3 joints, and they've revealed the mechanisms of failure. You know, it's very interesting. You can get some by with something that short, but it really worked. Another thing we have to deal with is, you know, the ride profiles that we get in MnROAD are relative. They don't represent a real road, because even during construction, we know that sometimes it takes 1,000 feet to get the pavers smoothed out and running. Well, we only have 500 or less long, 500 foot or less long test cells, so it's difficult with all the variables that go into these test cells to get something that's very smooth. So again, we have to be careful when we look at IRI values from these test cells that they're not going to fully equate to the real world situation. And as much as we try to control things during construction of these test sections, mistakes happen. So in some respects, it's disappointing. Other respects, it kind of says that these test cells are actually realistic to real world. You know, there's variability that gets built in them. We'll think we have everything calculated, and we'll run down, you have 5 feet left, and they run out of concrete, and they got to go run and make another batch, and all these things get built into these test cells. And we try to take the best measures we can to note everything down so that, you know, it doesn't become part of the study. We know that it was a construction mistake that caused that particular issue that shows up. So now that I kind of covered in the past 25 years, I want to talk about a little bit about the current studies going on at Minroad. And again, right now things have switched over really to under the auspices of the National Road Research Alliance. And you can see from this map who the members are. We have 8 states. We have the Illinois Tollway. We have the Minnesota Local Road Research Board. And just in the past couple of months, we actually got a new member of the state of Mississippi. So it's kind of still expanding as we go. But really what this is about is, you know, common problems, understanding, you know, how things work. And of course, a lot of the things are focused on cold weather, but I think, you know, some of it is not so much weather related. And I think even a state like Mississippi is still going to get things out of what we study up at Minroad. The current studies that started in 2017, and a lot of them are actually wrapping up. They're kind of a 3-year first phase anyway to a lot of them. A lot of focus again on fiber reinforced concrete, whether it was a thin overlay or slabs placed on grade. Just to understand how thin can you go on a city road, like in a development. Can you go down to 3 inches if you put fibers in the slabs? I showed before, again, understanding the long-term impacts of early opening. We did early loading both on new pavements, as I showed with the truck, as well as we had a number of repairs that we did that we also loaded early. Again, understanding how far can we push it and still not cause damage. We had concrete product evaluations, another round. I showed you before the ones back 2011, you had another round. In fact, this time, these were actually put on the old westbound section where we divert our traffic when we're doing measurements. We've also started to utilize that particular section and kind of consider it part of Minroad now. So that kind of gave us a little more real estate. It also has the capability of, it's a 1973 reinforced concrete pavement. So very, very old joints, and it gave us a good opportunity to see how we could repair those joints. A unique situation because of NRRA is the fact that we had attempted to build what was called a compacted concrete pavement at Minroad, and what it really is it's a roller compacted concrete with a surface texture. So it ultimately looks like a concrete pavement, but it's roller compacted. And due to the expense of constructing, you know, mobilizing a special paver to Minroad, that did not happen. However, the Missouri DOT, who is a NRRA member, said, oh, by the way, we're going to try one of these. So what happened was that we turned that into kind of a satellite Minroad test section. So we actually sent down a number of our expert staff members from Minroad and instrumented test sections down in Missouri. So that kind of demonstrates that the technology and lessons learned at Minroad can be applied to other sections in other people's states. And again, we have the reduced cementitious content experiment going on. Again, really pushing that down and seeing how low can you go, again, from a sustainability standpoint. What's the future of Minroad? Well, fortunately, we just heard yesterday that the next NRRA Phase 2 has been approved as a pooled fund, and it's open, and we're welcoming both renewing and new members, and you can see the information there. So if you're interested in joining, we welcome new partners, and we hope that we get all our partners back from first phase. And out of this is going to come that there's a number of test sections at Minroad, both concrete and asphalt, that are kind of running out of steam. The studies are over and things are falling apart. So at this point, we're tentatively scheduled to do a pretty major reconstruction of the facility in 2022. You can see we're going to be doing concrete, asphalt, big focus on sustainable materials and designs, as well as resilience. And also, again, starting to dabble in, we're getting a lot of interest, at least in MnDOT, in understanding the connected and autonomous vehicle interaction. We actually had a driverless vehicle rolling around Minroad, I think it was last year or the year before, prior to the Super Bowl. So it's very interesting. And then I highlight at the bottom, Minroad is about bold and wild ideas. If you think you can come out and build a Lego road or plastic bottle road, this is a place to do it. And that's really, the benefit of Minroad is you can really try some crazy ideas. If it doesn't work, we can tear it out, switch traffic on, and try a different experiment. Some of the newer NRRA studies, again, these are not exactly focused on Minroad, but it's other benefits that if you were to become part of the NRRA, we're looking at mitigation solutions to mitigate dull bar propagation cracking, jointless fiber roundabout that was constructed. We're studying the performance of that, performance of concrete overlays and full depth reclamation, effective using recycled concrete replacement, incorporation of joint faulting model into the BCOA-ME. We've learned from the first sections of fiber that the types of synthetic fibers, structural fibers that are kind of being used, they came out of the industrial flooring industry, are not really suitable to pavements if you're going to use them for something like joint load transfer. So there's a study starting up to, again, move towards seeing whether they can actually be developed or not. And it could be that they're not, but that's the ones that we're using and the dosages and even the testing regime that we're using, we feel needs much improvement before they can be used long-term for load transfer. And another one just firing up is looking at better understanding of the air void systems. So in summary, hopefully I've relayed to you that Minroad has really contributed significantly to the advancement of concrete pavement technology over the last 25 years. And those contributions have been anywhere from local to all the way to international. I think we've heard that there's next generation concrete diamond grinding going on in Australia. It's really touched a lot of local and international studies. There's an unlimited amount of data to look at. I think we have several billion rows of data. A lot of it is actually temperature data, so we could use that data to even help show the warming of the climate, because we have thousands of sensors recording every 15 minutes for the past 25 years. We've been successful in providing information for technical papers. We've been very active in seminars, collaborations, the development of testing equipment related to concrete pavements. We've developed a lot of pavement experts. It wasn't a real popular field back 25 years ago, but I guess I'm a result of being involved in this particular facility. We've also had a lot of opportunity for student development. Again, just the benefit of somebody being exposed to this facility has been really tremendous for a lot of students' careers over the years. With that, I'll end my presentation and take any questions you have. Thank you.
Thank you, Tom. We do have a couple questions here in the chat. Does MnDOT use expansion joints for concrete pavement? And it looks like Maria answered that, and she says we do not, only at bridges.
Yeah, there we go. And there has not been any studied at Minroad.
Yeah, it looks like they take care of that information. If anyone has a question they'd like to ask, you can certainly unmute yourself as well. Oh, we do have another one. Is there any effort in quantifying cost savings from the use of these outcomes from these researchers?
Yeah, there has been, certainly Ben Worrell at Minroad here has done some cost benefit work that you can look into. I don't have the specific name of the report, but obviously we get asked from time to time by our agency, why do you keep doing Minroad? And I think we demonstrated that we do have a good return on investment by doing this particular experiments at Minroad. We've never had any questions from the upper staff saying, you're kind of wasting your time. I mean, we have so many challenges in this, especially in our climate. We have one of the most extreme climates, going anywhere from 140-degree temperatures in the summer to minus 45 in the winter. So Minnesota's a little unique in that we just have such an extreme climate. There's always so many challenges in improving the pavements that we build.
Lauren? Yeah? Lauren?
Yes, yep.
Let me.
Oops, I lost Bernard.
Yeah, Bernard, I think you muted yourself.
Somebody's unmuting me. I don't know who. Anyway, we had a report and we had a presentation at TRB on the second phase of Minroad, quantifying the benefits. And the person who asked that question is Hosanna. I can share the link of that report with you after this meeting.
Okay, thank you. All right, well, if we don't have any other questions, we can certainly wrap up for today, and you can have a few more minutes before the 11 o'clock hour. And I'm sure Tom would be happy to answer anything that you do think of. His email address was there on the screen. And you can find his email on the NRRA website as well. So thank you for joining us. We don't have our next presenter lined up quite yet for December, but I will be sure to communicate who that will be, and that will be on December 15th will be our next one. So thank you for joining us and have a great day.